Hello again. We're going to now convert, well, not convert, we're going to decrypt and encrypt, or encrypt and decrypt. So when we encrypt, we take a sentence like this one, fish is a good boy, and we're going to go and get the numbers of the letters, like F for fish is the number 6 over there, I for in fish is the number 9, S is the number 18, and H is the number 8, and a space, let's say the space is this one, maybe the space is 22. Okay, the space is the number 22, and that will then be a number 22. So instead of F, but what we're going to do with this encryption is that we're going to add a number to it. So if F in this long string here is the number 6, we're going to add 5 to that 6, and we'll have the number what's 5, so fish, 6 plus 5 is 11. Okay, now we're going to have a separator for each of our numbers, and we can choose any separator one. I'm just going to use a little dash as a separator. Oops, sorry, that doesn't like the dash. Right, oops, still doesn't like my dash because okay, let's use a hash as a separator. Okay, we use the hash as a separator for each number. Okay, so that's the letter F. Can you see? And then for I, we have 9, so 9 plus 5 is 14, and then we're going to put a hash after that. And then S is on this list here, S is 19 plus 5 is 24, and then we'll put a hash after that. And H over there is an 8. Look up the H in our little alphabet, list of alphabets. The H is an 8, so 8 plus 5 is 13. Then we'll add a hash after that. Then we have our space. We look for the space in this list of characters, and there'll be symbols further on. Let's say it's a 22, so 22 plus 5 is 27, and then we'll have a hash to separate that. Then we get another I. So the I was a 9, 9 and 5 is 14. That is for the word is. You see how this is going on. And if we had a full stop over here, let's say there was a full stop in this list, okay? So the string is including a full stop. So therefore, in my alphabet over here, I must include a full stop as well. So we're going to put a full stop in that box, and that'll be number 23. So when we get to that point, it'll be 23 plus 15, and we know the full stop will be included. So that is the logic behind taking a sentence and encrypting it, and it's going to start off looking like this. Of course, that one hash, these are all going to be oh good, the wrong one, I took the wrong one. Okay, these are going to be, they'll look like this. The encrypted string will look like that. That's going to be our encrypted string, and it'll carry on, and it'll be a very long string. Okay, so we're going to have that story. That's going to be our encrypted string. I'm just taking each one of those, the 1 and the 1 and the hash, and then 1 and a 4 and a hash. So bear that in mind when we're doing this exercise. So we're going to take a sentence and get each character, and then join the numbers together. After we get our number code for each character, add 5 and join that number to a line, and then add a hash. Right, so to start off with, so here's like little program. There's my sentence. Fish is a good boy in an edit box called edit 1. Encrypt. Let's go and get it. But take note what I've created here. Oh, sorry about that. See that plus sign there? So irritating. Anyway, so what we've created here is, first of all, a constant called slist. And this slist is all of these, A, B, C, D, F, G, H, all in capitals, by the way. And then there's a space. That's also going to be part of our string. And actually, I should introduce a full stop, not so. So let's go and put a full stop there. So that's another character. Each one of these are characters. Even the space is seen as a character in this big string. Then I've added some. I must take that hash out. If my hashes are going to be my separators, I can't include that in my list of characters. But now let's go and get our line. So this must be a VAR. So the VARs are declared underneath our constant. So this is a local constant. In other words, this constant will only be used in this procedure. Yes, you can have constants over here as well. You could declare it there too, but you can't declare it in both places. You're either one or the other. So delete it from here. Right, so here we go. S-line. What is S-line? Going to be our edit box content. Edit1 dot text. But if you might remember, you're dealing with capital letters, and this fish is a good boy, must be uppercased. So let's go and uppercase it now, so we don't have to worry about that when we go and compare each character for that in that list. Okay, so we are going to go through the length of S-line. So we need a for loop counter, and we'll say 4k equals 1 to the length of S-line. What are we going to do? Well, we will put begin and end and do a lot of things there. We're going to get our character, S-line character number 1, and we're going to find the position of that character. So pos will give us the number up here in this big long string called what is it called? S-list. I called my constant S-list. So, and we're going to add 5 to that character number. So I must actually have a number variable inum be equal to pos of S-line character number k in S-list. So we're going to go through each character of our line from our edit box, and we're going to see where does it exist in S-list. Okay, so our num will be that value. For instance, F, where is it? It's 6, so our num will be 6. But what do we want to do? We want to add 5 to it, don't we? Plus 5. Yes. And then our S output, I'll call it S output. S output is going to be the string that we're going to build, because we want to display our thing already, don't we? So S output will be equal to S output plus int to string inum. So it'll be 11. Okay, inum will be 11. But what about the hash? We've got to go join a hash to it, don't we? Remember, F is the capital F is 6. 6 plus 5 is 11. So okay, it'll look like that, but it's actually going to be, yeah, it'll be 11, all right? When we convert that 11 to a string, it's going to look like this. So S output is going to be that plus a hash. So there we're converting our number 11 into string. But we've got to go and join a hash onto it, don't we? And there we have it. And then what we do here is we go and display. So this is all happening inside the loop. This output is being built. If for each character we're getting the position, adding 5 and joining it to the end, and now we're going to display it. Already pattern dot lines dot add. We're going to display encrypted this encryption. Oh, well, it doesn't matter, whatever you want to say. Encrypted equals S output. So let's go and see what fish is a good boy looks like actually in encryption code. So that should be exciting. It's probably going to be a long string. Right, let's go run it. Oops, I got errors. Errors. Oh, I left out a semicolon over there. And another error, yay. What did we do? Okay, S output is oh, I've got to use a. How stupid can I be? I forgot to put single inverted commas there. Come on. Okay, encrypt. Ooh, it's a big long string. See that? Look at that. Okay. Right, now what if you want to go and reverse it back again? Well, first of all, if I'm going to put that big long string in this edit box, I better go and make that edit box rather large, eh? There we go. So, I'll put my decrypt button over here now. Decrypt, we're going to take that long string, this one, go through each line one at a time. When we find a hash, well, we're going to have to do something, eh? So we have to look for our hashes each time so that we can go and get our encrypted message. We've got to get that number, you know. We've got to get the number 1 and 2. Well, we can use a for loop. Yes, we can use a for loop for this. We can go through every single character, which we are going to do. We're going to go through every single character and let's see if it works. Alright, so it'll be fun. We're going to go through each character one at a time. When we see a hash, then we're going to join those two characters together, and then yeah, let's have a check what's happening. Let's go through it very carefully. Right, so what will my variables be? Oh, okay, fine. I decided I'm going to use a for loop. And S output, well, yeah, I'm going to build a string. Okay. Of course, we need to have our S, let's call it X text. Well, let S input. Let's call it S input. The actual encrypted message, and what's going to happen is we're going to get S input from this edit box as well, because I'm going to type it in there, just copy and paste it basically. So S input will be our edit 1.text. Now of course we do not have to put in, we don't do uppercase at all because it's all numbers. Okay, you can see it's all numbers. Okay, so now we could use a while loop here, but we're gonna try to the for loop. Right, first of all, we know that S output, in other words, our decrypted string, S output, what we want to display, build and display at the end of the day, set it to empty string. And I'm going to go from the first to the last of our input. What am I going to do? Yeah. Well, first of all, I want to make sure that I'm not dealing with a hash. We don't want to deal with hash. If S input square brackets k, if that is not equal to a hash. What are we going to do if it is equal to a hash? Well, let's first think of what we're not going to do if it's a hash. Well, we are not going to we're going to build a number up. Okay, so what shall I call that number? Snum. Let's make another variable snum. I'm going to build a number up. If it's not equal to hash, I'm going to say snum equals snum plus the s input character number k. So I'm going to build this number. If it's not a hash, I'm going to say, okay, our snum is that, and then it's that. And then I must take that number and subtract 5 and see what it comes up to. Well, obviously, if I build this number up and it's 11, 11 minus 5 will be a 6. And then I know immediately, well, there we go. We're going to use character number 6, which in this case will be an F. So, first of all, I'm building this number up, okay? If it's not a hash, else, if it is a hash, then I'm going to take snum, okay, and I'm going to convert it to an integer and add a hash to it. Well, I'll do a begin and end here. I'll say snum equals string to int. Sorry, I must make an integer now. I number. We've got to get an integer, string to int, I number, string to int snum, and then we will, what did we do before? We added a 5, eh? So now we have to subtract a 5, because we added a 5 before, so now we must subtract a 5. And then we're going to go and look up what our number is inside this S list. Now we're going to need this constant as well inside this button click too. So you could very well have just made it a global variable here, a global constant, but we need the same constant because we're going to go back and refer to the same constant. It's called our cipher. Could have called it S cipher here. Right, now because we added 5 there, we've got to subtract 5 over here. In our decrypting, we've got to do the opposite. And then our S output must be equal to S output, join that to S list, character number, I number. And then you might wonder, when did we put snum, because we're building snum here, and we never set it to an empty string, did we? No. Well, we can set it to an empty string right here, but after we have dealt with snum over here, we've got to reset it to an empty string, so we can go and build the next one after the hash. Because here's the hash over here. Because when we finished with snum will be those two, and then, because it is a hash, because this character is a hash, we build snum. We've built snum, we've added it, we've checked up over here that it's 6, and then we've got to, what are we doing? We minus 5. Okay, it was 11. 11 minus 5, and then we know that it's 6. And then that F for fish is going to be added to S output. But now snum, we finished with it. Snum was our 11, remember, that we built up over here. If it's not a hash, we built up snum here. Luckily I set it to an empty string before our for loop. So I built it up here. And then what did we do? Well, exported there. So each time we find a character that's not a hash, we build up snum, build up snum. When we find a hash, we take snum, convert it to an integer, subtract 5, look up the character number in slist over here, see what character it is, and join it to our output that we're going to display, which will be the original message. So after all of this is done here, after this loop is finished, red pattern dot lines dot add is output. So let's see if that works. Encrypt. Okay, so there's my encrypted message. I'm going to copy and paste it and put it in there and click on decrypt, and there it is. Okay, it is in capitals, but it works perfectly fine. It worked fine with the for loop, but technically a while loop would have been better. So what we'll do, if you want to convert this to a while loop, we'll say while k is less than or equal to the length of s input, do, now of course k will have to be equal to something before we start, and then we will increment k over here. So, and let's see if that works. That's actually a more efficient way to do it, using a while loop than a for loop, although it did work with the for loop. So encrypt, and then go and get our code and reverse it and see if it works with our while loop. And yes, so it is better to use a while loop over here. And that will be the end of that.